So looking at this, cosine theta times cotangent theta all over 1 minus sine theta minus 1, and that's a big 1 there. And you want that to equal cosecant. The idea of the day is common denominator, which means I think step 1 on this is I want to get a common denominator between those two. Yes? And my common denominator would just be 1 minus sine theta. This side's already just 1. So on this side, do I need to do anything to this to make it have that denominator? No, it's just going to say cosine theta, cotangent theta. But be careful over here because you're subtracting 1 times 1 minus sine theta. So minus 1, but then negative 1 times negative sine, that's going to become a positive sine theta. You with me on that math? In second hour, they decided that I made this worse instead of better because now it even looks worse than it started with. Definitely doesn't equal cosecant yet. Any ideas? I just canceled this sign out with this sign and this 1 with this negative 1. No, that's not allowed. Forget about the bottom for a minute. Is there anything I could do right now? Either one of you? Well, I was kind of thinking on like, gosh, my feet scared. Alright, what do you think?
I was going to say cotangent and switching, but...
We could change cotangent. What is cotangent? Cosine over sine? It'd be really nice if it was sine over cosine, right? But it's not. I'm going to just write this up here. Cosine over sine. So if I multiply those together, I get cosine squared theta over sine theta. That's just putting cosine and cotangent together. Minus 1 plus sine. And I think one of the hardest things about these is that you don't know if you're doing the right thing, right? Like you don't know, you can't see the light at the end of the problem yet because it doesn't look so good right now. And everyone's different. How do you know if you're starting the right way? And you just have to try things. It happens that sometimes you try it and it doesn't work. Because right now it's not really looking so good. But as long as you have another step you can take, I say keep going. So now look at the top of this. Now I have a fraction again. Could I now get a common denominator with all this? Anytime you have fractions and stuff that's not fractions, common denominator is a good step. Which means my next step is I'm going to make these have a common denominator of sine. So now on the top I'm going to have sine, and then I'm going to have on the bottom 1 minus sine. And I got to get all the tops to match. So this one already has sine, so I'm going to do nothing to it. That's just going to be cosine squared, right? What's this minus 1 going to become if I need it to have sine on the bottom? Minus sine, so that's going to be like sine theta over sine theta. And then on this one, if I need to make it sine over sine, sine times sine is sine squared. So that's getting a common denominator between these things, all over sine, all over 1 minus sine. And again, as long as there's something else you can do, don't give up. So look at what we have now. Anybody see anything we could put together? We have this one at 5-1. We have cosine squared and sine squared. What does that always equal? 1. So could I rewrite this as 1 minus sine theta over sine theta over 1 minus sine theta? It's a whole lot of sines. That's a complex fraction. What do we do when we divide fractions? We multiply by the reciprocal. If you see up here that it's a complex fraction and you want to go ahead and multiply it up instead of writing the steps, I'm okay with that. Right now that's over 1, right? So this is like my top fraction. I tend to like to make this fraction bar extra long so you can see top fraction divided by bottom fraction. So you could write this as 1 minus sine theta over sine theta times the reciprocal of this, which would be 1 over 1 minus sine theta. Oh my gosh, I can't spell cosecant anymore. Do you see it? This is where, when I get to this point, I start seeing that stuff's going to be able to cancel out. And if you just wrote cosecant there, I'm okay with that, but I'm going to write 1 over sine theta equals cosecant theta equals cosecant theta.
Well, you were right. That's your bit rough. Thank you, Danny.
A little bit rough. Anyway.
Okay, so whenever you, I don't know why, but I could get lost in the proof, but cosine and then sine gets electrical.
It's just common denominator. Like, I really don't know what else to say except for write it out. Like, write out cosine squared theta over sine theta and show that in between steps. Write that as minus sine theta over sine theta, and then write that as plus sine theta times sine theta over sine theta. Like, show getting each one as a common denominator, but you've got to be able to get common denominators to do these problems. Like, and if you get a common denominator, then they're all over sine, and you're just taking the tops of them, which is where that's all coming from. Yes, common denominators is the theme today.
How do you know that you're supposed to wait to multiply by the reciprocal?
It doesn't help to multiply by the reciprocal. One, if there's nothing to cancel out, like I always wait till the end because usually at the end is when you cancel stuff out. You can't multiply by the reciprocal up here because you have separate things. Like you don't want to multiply by the reciprocal until you have one fraction over one fraction. So to me, I always wait until I can condense it down and then I flip it over. Could you flip this up right now? You could, it's just not going to be as pretty. So I always wait till the end when I have one fraction together over one fraction. And let's do another one with common denominators so that maybe it will all come together. Well, this is exciting, right? See how much I love to grade these. Oh, look how exciting this one is. Oh my goodness, 2 variables. You need a pen, Savannah. You need a bucket to throw it in. You look all pale.
I had this like big burst of energy after I donated blood, and like an hour later
Yeah, I think donating blood on straight proof day, I should not recommend. rough day. Does one side look better than the other? No. They both look about the same. But here's what you want to think about. If you want to take this and turn it into this, what do you think would be a good first step? You want to take this and turn it into cotangents. I think you're right. Tangent can be sine over cosine, but if we want it to be cotangent, you see how I think it makes more sense to change tangents into cotangents? That's why I think it's helpful to look at what you have. And what if you wanted to work with this side and turn it into this? What do you think a good first step would be? Change all those cotangents into 1 over tangent. So if you change the sines and cosines, it's not impossible, but you're going to make a whole lot harder problem. Okay, so look at what you have. I'm going to work with this side because I just like this side better. And my first step is I'm going to make this really ugly and turn all those tangents into 1 over cotangents. Yes?
Could you not just like flip them all at the same time and get cotangent x plus cotangent y equals
No, because you can't flip the addition, right? Like you can only flip each function. Like we can flip all this on the bottom because it's multiplied together, but you can't just say that this is just cotangent x plus cotangent y. Does that make sense? Like this becomes 1 over cotangent x plus 1 over cotangent y, right? All over 1 minus 1 over cotangent x cotangent y. And sometimes they gotta get a little bit uglier before they get better, so keep that in mind. In second hour, they were all complaining about me making them rewrite this every time. And I said, one, it's a proof, you can deal with it. But also, one reason that I make you rewrite it is you need to make sure you work vertically when you do a proof. And by rewriting it, it kind of forces you to work vertically. If you don't rewrite it every step and you just put equal sign and then at the end you rewrite it, I'm not opposed to that. I'm not happy about it, but I'm not opposed to it. Just make sure you don't work horizontally with your proof because I can't create that mess vertically. What do you think we're going to do here on the top of this? What am I going to do with these two here? Common denominator. What do you think I'm going to do with this on the bottom here? Common denominator. Can I do it at the same time? Maybe. I'm going to get a common denominator at the top. I'm going to get a common denominator on the bottom. And honestly, this looks ugly, but if you just get common denominators and you know to multiply by the reciprocal, it's not nearly as bad as the last one, I don't think. And again, if you need to show the step for a common denominator, show the step. The common denominator is going to be cotangent x times cotangent y, because you need both of them, which means multiply by what you don't have, which means this side you're going to multiply by cotangent y, this side you're going to multiply by cotangent x, which is going to become cotangent y plus cotangent x. Yes, that's the top. And then I like to draw a big giant line. On the bottom, my denominator is cotangent x cotangent y, which means on this side I do nothing to it. What's this going to become? Cotangent x cotangent y. And again, notice what happens if you get one fraction over one fraction. Then you can multiply it by the reciprocal. Magical cancellation will happen. Right? This one looks ugly, but I don't think it's that bad. I mean, it's bad for people that want to fit everything on one line of their paper. I say just use the paper if it's good for you. It's good for the paper. In second hour, some of them pointed out that they know, since these are the same denominators, that when you flip it up, it's going to cancel, and they're just going to cancel them out without rewriting it. As long as you show that you're canceling them out and you know they're going to cancel out, I'm okay with that. But I think it helps if you don't see that, to rewrite it. The top function stays like this, and then I'm going to multiply by the reciprocal. So now I get cotangent x, cotangent y on the top, and cotangent x cotangent y minus 1 on the bottom. And does that equal what I'm supposed to equal? It does. It's really messy, but it does. I'm going to be a slacker and not rewrite it since we're running out of time. So I get cotangent y plus cotangent x over cotangent x cotangent y minus 1 equals cotangent y plus cotangent x over cotangent x cotangent y minus 1. Nice to see you, buddy. There's one very similar to this on your homework, one of the first ones, I think. In second hour, some of them try to do what Sam suggested earlier with changing the sines and cosines. If you see tangent on one side and cotangent on the other side, don't change the sines and cosines. Okay? It's going to be a disaster. So, this is your homework. 16, 28, 36, 45, 46, 49, and 52 I'll tell you that the last two I think are the easiest ones on the homework. I've circled 45 because it's a doozy, let me tell you. My advice to you on 45 after me trying it a different way is to change 45 to sines and cosines. And I'll tell you what makes 45 maybe the worst proof I've ever done is that you have to at some point factor a difference of cubes. What? Who remembers I do that? So I wrote these formulas up there for you. Like maybe at some point on 45 you end up with this sine cubed x minus cosine cubed y. Who would give you such a problem? So you have to use this formula. So I thought you could just write it down, you know. But the rest of them are doable. Common denominator. The bell's going to ring in like 2 minutes. I'd really like to help you on 16 if you want to get your book out and write it down on your paper. And then even if the bell rings, I'll just hold you hostage and give you an answer to one of the problems. Because I feel like this will help you on the worksheet tomorrow. I'm not going to be here tomorrow, Colton.
So what did I miss exactly?
You missed some examples.
How many examples?
2. And you missed going over most of the homework.
I understood that.
There you go.
What is that breakfast thing on Thursday?
It's just senior breakfast. It's no requirement that you go to, but they just feed you pancakes and such. We'll get to that. I wanted to show you 16 because I feel like 16 is the first one that we've done that makes you add something into the problem. What do you think would be a good first step on 16? I know. Let's change tangent and secant into fractions. So this would be sine x over cosine x plus 1 over cosine x equals cosine x over sine 1 minus sine x. And 16 starts out so nicely because you're like, oh my gosh, is there any common denominator? I don't even have to get a common denominator. What a great problem. And then you get sine x plus 1 over cosine x equals cosine x over 1 minus sine x. And the hard part about this one, and other ones like this,
The Dakota Meinhardt, the guidance office, Dakota Meinhardt, the guidance office, please.
I don't know how to get the answer to this without introducing something into the problem, which I despise this every day. Why do we call so many people's office every hour? Never mind has this happened at school, except for this school.
Any Claire Perry's office, please? Claire
I don't
Perry's
care. I'm
office.
not letting you leave. They're just staying here. How do I move this to the top? How do I get this to be in the bottom but negative? These aren't squared, so you can't do Pythagorean identities. You can't just move stuff around. You can't cross things out. But what you can do, what if, this is not what we're going to do, if I wanted to multiply the top of this by 7, I'm not allowed to do that. But what if I multiply the top and the bottom by the same thing? Am I allowed to do that in a problem? Because that's really just like multiplying by 1. You can't just switch them. Right? You can multiply the bottom up by 1 over cosine, but that's not going to get you anywhere. What are you going to multiply by that's going to help you over here? I want a cosine in the top, right? So to me, I'm going to try, what if I multiply this as cosine over cosine? I'm not really changing anything because cosine over cosine is really just 1. But sometimes if you get stuck and you can't figure out what to do, multiply by something that you need in either the top or the bottom and see what happens. This is actually different than how I did it on my paper. On my paper, I actually multiplied by sine x minus 1 and it worked out the same way. But on this one, we tried this in second hour. And now on top, I'm not going to distribute that. I'm going to get cosine x times sine x plus 1. And what do I get on the bottom now? Cosine squared. I'm just not going to write the other side for now since I'm holding you hostage. So, check. I got the cosine on the top. I need to get rid of this. And I need to change this into sine 1 minus sine x. Can I change cosine squared into something with sine in it? Pythagorean identity, now that it's squared, I could write that as 1 minus sine squared. And I'll just stop here and I'll let you finish this. But what could I do now with the bottom of this? It's a perfect square minus a perfect square. Could I factor that into 1 minus sine x and 1 plus sine x? And that's going to cancel out with the sine x plus 1. And I think you're going to get the answer. I think that's the only one on the homework that's like this. But on the worksheet that I'm going to give you tomorrow, there's a couple of them that you've got to multiply by something. And so my advice to you is, if you get stuck on something and you're like, I don't know how to do this, multiply by a trig function. I'll send an email out, but if you want an individual pass because you feel like your teacher won't pay attention to the email, stay here and I'll give you a pass.